And welcome everybody to our workshop today. We'll be getting started here really soon. First thing though, to start you with some cool tunes. And for those of you who are joining us for the first time today, welcome. Notice the link that I just put up on the screen in the QR code. That is to get you registered for your free tier Astra database. We will be using Astra today for the workshop. And matter of fact, I've seen some certification, some exam certification voucher questions already coming up. One of the requirements for you to get your certification, or I'm sorry, to get your voucher for your certification is in fact to spin up a free tier database and use it. We're going to use it today. And for those of you who have been with us before and you have an existing database, it's a good time to unpark it. If you haven't used the free tier in about a day, it might park. Because again, in order to get your voucher, you will need to do the exercise with us today and use the databases. And with that, I welcome everybody to our intro to Cassandra for Developers workshop. I am David Jones-Gilardi, joined today by Erick ZIETLOW. Hey, Erick.
Hello, hello, hello.
How you doing?
Doing all right. All right. We're going to get into some good stuff here today. Yeah, just real quick in the chat, how many of you have attended one of these workshops before? Can I just get a thumbs up or a me or something along those lines? Let's just see real quick.
We are going to technically ask that in the survey, but let's see how many thumbs up we can get.
But yeah, it's nice to see. So, okay. Well, all right. Well, we'll just jump right into it then. This is a very, very basic level session. We're not going to go into any advanced topics. This is all just intro to Cassandra for developers. It's a very accurate title. So if you're years of experience with Cassandra, you're into the data modeling and all that stuff, this session probably isn't for you. Also, if you're an ops person who doesn't have any interest in learning any sort of development, again, this session probably is not for you. We're basically skipping all of the ops today and going straight to how would I actually interact with my database as a developer. So just kind of level setting there right up front, and we'll get into it. All right, so I'm joined today by a whole lot of different people from our developer advocate team. Obviously, David, who gave that wonderful intro, is here with me on screen. Hello. We also have some people in chat. We got Cedric, we got Bettina. I don't think the other Eric is actually here at the moment, and he's going to correct me if I'm wrong there. In addition to Alex, who is one of our European advocates. All right, so a couple things, real quick housekeeping. We have obviously the YouTube stream if you're watching on YouTube. We also have a Twitch live as a backup. We only answer questions off of the YouTube, so just keep that in mind. We also have Discord for questions as well. Links are all provided. And if you have a question, feel free to ask and we can provide those links as well. We're going to be using Astra, and I'll get into that a little bit more today, but that's going to be the database component. And then, of course, we have our quizzes. David is going to be conducting those for us here. That's just going to use the Menti app, so Mentimeter. If you don't have it on your phone, please go and download it. It works much better in the app, but you can use the website as well. Mm-hmm. All right. Lastly, just resources-wise, we do have community.datastacks.com. That's kind of our interaction hub with you guys. So if you have questions, if you have topics that you want to discuss, that is a perfect place to go and raise those issues. Doesn't matter time of day or night. There's almost always one of us on there in some capacity or another. So please ask your questions there. We do have academy.datastacks.com, and I will throw in just kind of a little bit of a plug there. There's also dev or /dev. So datastacks.com/dev is kind of the other resource place where you can get teaching, you can get self-service courses, and it's all entirely free. All the content we provide to you, we try to keep it free because, frankly, in order for developers in the world today to be successful, they need to have access to this stuff. So, absolutely. That's all there for you. Please check it out. Please use it, and please provide us feedback. If there's something that worked for you, great. Let us know. If there's something that didn't work so well, let us know as well. We use your feedback to improve what we have. So, lastly, there is Discord. This Discord doesn't go away after the session. We are going to continue using this. So, if you have questions over the course of the week, feel free to throw them in there. Generally, one of us will pop on and provide an answer or direct you to a resource or something along those lines. All right. So I brought up this whole Astra thing, right? Not going to get into any sort of marketing spiel, but just for today, the reason we're using Astra is because it's fully managed Cassandra, and it means we don't have to manage any of these ops ourselves. Historically, when we do these, events at maybe a conference or something, and we'd have a workshop, we would spend about half the day spinning up Cassandra and getting it configured for everyone and making sure everyone was actually up and running. And it was all this big headache and just took forever to actually do. With Astra, we're going to take about probably no more than 5 minutes to actually spin everything up. And then we'll just be able to get our hands dirty and actually use the stuff in a 2-hour session. So really, really big help for us today. And again, like David said, you are going to have to actually use the Astra today in order to get your certification voucher. All right, Astra is globally scalable, just like Cassandra. We eliminate all the operations because it's a self-service, basically a single-click kind of setup. You type in a little bit of info, hit go, and it spins up a database for you. And it says 10 gig. It's actually a 5 gig free tier. We better make a note of that to fix that in the slides for the future. But yeah, it does have a free tier, so there's no credit card required. We're not going to take your personal information or anything like that. For today, you just create an account and you can spin one up, and it's yours forever. So, okay, David, here's our first mentee. So take it away.
All right, let me go ahead and pop that over. You should see Menti now showed up on the screen. So if you would, now Menti, what we're going to use Menti 4, as Eric mentioned, for our quizzes, but also some initial survey questions. It kind of helps us kind of guide, the kind of tone and the things that we say here in the workshop and understand all of you a little bit better. So if you see at the top there, if you go to menti.com, and the code is 2922388. If you could go there, I'll give everybody just a moment to pop up on there and then give me a thumbs up. That's right. I see some thumbs up already showing up, so that's always wonderful. Thank you. I appreciate that. And for the number of you in here, I'm going to let you all, let's see, maybe we need to get to 50. I think we need to get to 50 in Menti. Now, something else to note about the Menti is when we take the quizzes, if you are one of the top 3 winners of the quizzes, you're going to get a swag box, right? So definitely want to get your thumbs up in there. All right, we're so close. 10 more to get to 50. We can do it. And again, it's menti.com, code 2922388. Okay, we got to that number. It doesn't mean stop, by the way, but
right, we got 170 in chat here, so
yeah, exactly.
Keep on coming in, guys.
All right, so here's the first one. Now, given what I saw in the chat about how much experience do you have with Cassandra, I have a feeling we're going to have a lot that have never used it. It looked like we had a lot of first-timers coming in.
Oh, that's perfect. This is the section for you guys. This is
that's right.
Exactly who we built this session for. So this is wonderful.
That's exactly right. And by the way, just to add something to what Eric said earlier, if you are somebody who has a little bit more experience, or if you are interested in ops and admin and stuff, that's right. We're not going to get into that, but ask your questions anyway. That's what we're here for. So, wow. So we have like over 70 folks who've never used it. That's amazing.
Yeah, and only a couple who have been in it for more than 3 years, 1 to 3 years there. Yeah, that's incredible.
Excellent.
All right.
I'm going to move on to the next one. Thank you, everybody, for that. So have you been to any one of our workshops before? Let's see how many. I saw a lot of first-timers in the thing, so.
That's awesome. Well,
wow.
Welcome.
Yeah, right?
And genuinely welcome. This is wonderful. Generally, there's a little more of a split, so this is amazing.
Yeah, that's awesome. And for those of you who have been, the 14 who've been to one of our workshops, 15, been to one of our workshops before, welcome back. Thank you. Nice to see you again. All right, next one. What's your main motivation for learning about Cassandra?
It's awesome.
We should have an "it's awesome" answer. Yeah, honestly, we need to just put that in there.
Okay, yeah. So a lot of people wearing multiple hats, it looks like here. About 50-50 between
that's a pretty
developers.
good split. Okay.
Yeah.
All right,
Wonderful.
excellent. Everybody, thank you for your answers. And how did you hear about this workshop? By the way, you can choose multiple options in this one, just so you know.
Yeah. Instagram. Ooh.
You know, Instagram is actually that seems to be a place where a lot of folks find out about us. So that's kind of cool. And Eventbrite is always really good too.
And Through a Friend is awesome. Lots of interesting stuff with Through a Friend. Wow, LinkedIn.
I'm actually really happy to see Through a Friend. That's great.
Yeah, that's the best kind of advertisement we can get is when you guys like what we do and share it with others. So
I'm assuming that those who are Through a Friend, that was a positive endorsement, or you'd have not shown up. But by the way, feel free, if you have a story, feel free to tell us about it in the chat. We definitely want to know. All right, last one. What do you want to do with your new knowledge? By the way, this is all anonymous. You don't have to worry about anyone. The Get a Better Job one I always thought was kind of funny, right? Like, it's like, I just said out in the public, externally, I want to get a better job. I hope my job's not watching. Yeah, it's all anonymous.
It's anonymous, though.
Yeah,
it's anonymous.
Yeah, you're all good.
A better understanding. Yeah, that's awesome.
And for those of you who want to build an app with Cassandra, you know, if you do something like that, you should really reach out to us and let us know about your app. Because we definitely are looking for more and more individuals out in the community who are building apps with Cassandra. And we do have, you know, we're starting to build like a curated list of example apps and stuff. So there's pipeline there if you are building apps with Cassandra.
And also, if you're doing something cool, let us make you heroes. Because honestly, we if you're doing something cool with Cassandra, we'd love to promote you.
We want to talk about it. Yeah.
Community.
Yeah, exactly. All right, excellent. Thank you so much, everyone. Now, please leave this Menti open because we are going to use it for the quizzes later. And then before we move on, I want to do one other thing. I realize sometimes, I realize sometimes that hopefully it doesn't feel like we have too many little apps for you to take a look, but we're going to experiment with something today. So yes, we have you in the chats, both in Discord and YouTube. But I would like everybody to go ahead and take a look at Slido and pop in there, please. If you go to slido.com, the code is 88821, or just scan that QR code with your phone on your smartphone, and that will pop up to the Slido app. So if you've not used it before, what this will allow us to do is we're happy to take your questions wherever. But with so many people on, and sometimes a lot of people are asking the same question, it can create lots of chatter in the chat. So what I'm going to ask you to do today is go to Slido for us, take a look at our particular Slido presentation, if you will. And what will happen is, if you have a question, any question at all, then ask it there in Slido, and then everybody else can upvote it, right? So that way, if other folks have the same question, then we'll see it bubble up to the top. We'll know that it's got some weight to it, and we're going to try and answer it. Now, our intent is always to answer all the questions we get during these sessions, but we really want to go ahead and experiment with this. So again, I implore all of you, please go to slido.com, use the code there or the QR code, and ask your questions there. If you can start there with your questions and we'll use this interface, that'd be wonderful.
Yeah, we're all about failing fast. So this is an experiment.
All right, with that, I will pass it back over to Eric. Eric, there is your screen.
All right. So with that, we're actually going to jump right into the first exercise. This is kind of a prep exercise. It's not really getting into the meat and potatoes of what we're doing here today. But if you follow along with me, we'll get through it here real quick, and then we can get into the content. So what we're going to do here, if I can get someone to drop the GitHub in chat there, we're going to go to this GitHub. Now, this README here in the Intro to Cassandra for Developers GitHub contains pretty much the entire lab we're doing today. If you want to come back and do it later, that's fine too. If you want to share it with friends, that's totally cool. Everything you need to do the labs is contained in this README. So what I'm going to do is I'm going to go through each time we have a lab, or each time we have some hands-on, I'm going to go through the content. I'm going to run through it. I'm going to give you guys a little bit of time after I've done it to kind of finish up, and then we're going to move on. So it should be pretty easy. There's this nice little table of contents at the beginning too, with each of the individual sections. We're just going to go to the Create Your Astra Instance, which just happens to be right below the table of contents. So first things first, we got to get you all to astra.datastacks.com. That is the self-service Cassandra by data stacks that we will be using today. Now, I have already opened mine up and logged in. If you don't have an account, I'm going to give you just a couple minutes here, or just a couple seconds here. Go ahead and create an account. You can log in with a Google account if you have a like Gmail or something like that. You can totally just use that to authenticate and get yourself in there. Give it just a moment here. And people should be about there. If you already have an account, feel free to use the one you already have. We'll kind of walk through what you need to do to get that working. Okay, so the first thing we're going to do once we hit this landing page is we're going to select the free tier. Now, the free tier is the one where you don't have to put in a credit card. If you selected one of the other plans, you'd have to put in a credit card. It would charge you money. We don't want to do that for this workshop. We want this to be free to you. So go ahead and select free tier, and you'll notice that Google Cloud is already selected for you. So we're not going to touch that. We're just going to leave it the way it is. Now, for region, select the region that is closest to you. If you're in Europe or Asia, I think Europe West is still the closest for Asia. And then, of course, U.S. East, if you are in the U.S., would be the one to select. Go ahead and click the Configure button down here in the lower right-hand corner. Now, these values that we're going to put in all these boxes do need to be fairly specific. You need to go ahead and use the same values I'm using. Otherwise, we'll kind of run into some hiccups here today. You'll notice, if you scroll down in the README, that all of these values are actually in the README as well. So I'm actually just going to copy paste them, make sure we're not fat fingering anything. So killer video cluster, and then for your database name is literally just the database name. It's the way we identify in the UI which database it is. So if you had, say, multiple things going, you could keep track. Key space name. This is key space. I'll get into a little bit more of it in a few minutes on what it is. Just for now, understand that basically that in a traditional database, you have either the database keyword or the schema keyword. You know, that thing that holds the tables, that bucket that tables live in. That is what the key space is in the Cassandra world. So we're basically saying what is that bucket, and we're just naming that.
Hey, Eric,
KB
real quick.
user.
Sorry.
Yeah.
Once you finish this up, we need to go back, if you would, to the initial landing page. I would say go ahead and finish this up for the folks that are there. We do see some questions about folks who missed that part, so then I'm going to ask Eric to go back so we can take a look at it once he gets through what he's doing here.
I'm actually going to do that now. Then I'm going to cancel out of this because as soon as I click create database, that's all going to change. So you should see this dashboard or something pretty close to it. Just go ahead and click add database.
And matter of fact, if you're, let's see, I'm trying to see, a couple folks weren't seeing that. And maybe what we could do is, if they're getting here, to kind of give us a thumbs up, let us know that you are in fact seeing the screen. Now, I'll just
a question here for India, which region to select? I would select Europe.
Yeah.
I think that's probably the closest one to you guys currently.
And something to be clear about, if you notice, there's only 2 regions that are available right now, but that's because you're using the free tier. If you were to use one of the other production quality tiers, you have a lot more regions that open up. That would be, say, if you're in India or something like that, that could be very close to where you are. But it is on the free tier, so there's just more limitations on the regions you have. But yeah, Europe is the way to go.
Yep.
Rashid in YouTube is asking, database name and key should be the same as you mentioned. Yes, for what we're doing for today, exactly. Eric is highlighting them on the screen right now. He's going to go ahead and put those back in as he creates the database. Yes, please use those values if this is your first database. The reason why, for troubleshooting later with everybody, all of you with us today, if anyone runs into any particular issue or something, or if you need help, it's so much easier actually on us if we know exactly what database name, key space, all that stuff you use. So yes, for today, please use those values. However, if you're doing this for your own applications, you can create whatever key spaces and names and everything you want.
And it's important to note too that the database name and the database user password, database username and database user password are both the values that your driver is going to use to authenticate against your Astra. So that's essentially that you're not going to use that to log into Astra. That's actually how we talk to Astra. So I'm going to go ahead and create database. Oh, that's not good. Response not successful. Receive status good. Let me refresh here quick. Rerun through that. I've had this open for probably way too long, so it's most likely just a session timeout. Go ahead and do this. And one more thing. And ba-boom. Create database. Uh-oh. David, I might need you to...
Yep, let's see. All right, let me get... I'll take a look. Now, funny enough, you know, we just released...
brand new update.
Yep, for the UI and stuff.
I'm just going to sign out and sign back in and see if I can get that working.
So Cactus Truck, that's a great name, by the way. Cactus Truck in YouTube says, so for every database, we will have a user and password. So once you create the initial database, like what Eric is doing right now, you're going to fill that in. Now, after that point, though, you can add a key space, and you're going to use the same username and password that you created for the initial one for that key space. So really, it's just this first one where you're going to have that user and password. But then after that point, now if you create multiple key spaces, you're going to use the same credentials for those key spaces and such. Now, if you create a whole new database, like let's say that you are not working in the free tier and you're creating multiple databases in the other one, any database will have its own username and password. Just understand that you have the database and then you get multiple key spaces in there. That'll just have that one username and password.
Right. All right. So yeah, it was just a session token. I've had this open since early this morning, and they timed out my token, which is totally fine. That's actually good security. So, all right. So when you hit the create database button, you should land on a page like this. You should see that status is something like pending. That status changes to active, that means your database is then accessible. Oh, it just did that there for me right now. I'm going to go ahead and I'm going to click on the database name there itself, and we can just see some basic information. We can see what our username was we had configured. We can see what our key space is down there. We can see our provider, just all the basic information you'd want to see on your actual database itself. All right, so with that is the end of our first section here. We're going to stop right before this section 2, create a table. So go ahead and stop there, and we are going to continue on. So we got our setup taken care of for today. That was really quick compared to trying to stand up your own Cassandra and get your own infrastructure set up. Took a fraction of the time. We're basically going to take advantage of that by now giving you useful information. So what are we going through today? We're going to cover the concept of tables, the concept of partitions. Partitions are a very key thing in Cassandra that you don't have in the relational world. We're going to go over data modeling, how it works, why to do it, and kind of the process to actually accomplish it correctly. And then, of course, some resources for after this workshop, what's next at the end. So let's get into tables and partitions here and go from there. All right, discuss a couple terms here. A cell is your smallest unit of data. It is the intersection of a row and a column. So just like in a relational database, if you ever use like any sort of MySQL or any other relational database out there, you've probably used rows and columns and returned cells. Cells are your smallest unit of data retrieval. Cells store data. Rows are records. They are groupings of cells that are related data. So if you have, say, a username, a password, an email address, all stored in a table, those would generally be stored for an individual user on a single row. Pretty simple concept again. Columns are then the individual piece of data within the table structure. So if you had your address column, all of the users' addresses would be stored in that column. Now, in Cassandra, we have this concept called a partition. Now, a partition is a grouping of rows that are related and they're distributed together across the database. Because if you're familiar at all with Cassandra, you'll know it's called a distributed NoSQL database. the way we distribute data is we chunk things up into partitions, and then we shoot them all over the place, and we retrieve them based on what's called a partition key, which we'll get into. But for now, just understand your partition is your smallest unit of data distribution, and it is a grouping of rows. All right. So a table is exactly what you think it is. It is a grouping of rows that all of your select queries, all of your insert queries are going to reference that table. So you can think of it almost like a spreadsheet in some ways, where each spreadsheet is its own table. It's a very similar concept. If you've never used databases before, it should feel really comfortable if you ever used like Excel or Google Sheets or anything like that. It's a very similar sort of concept for the structure of how you store data. So rows, columns, and you can reference things accordingly. Okay, so our overall data structure then looks like this. We have our key space, which remember we created in the UI. That's our bucket that all of our tables are stored in. Our tables are then made up of these partitions, which are made up of rows and columns. And if I were to just do a select star on one of these tables, it would just return all the partitions. So the basic structure should be pretty familiar to anyone who's used a relational database in the past. The only difference there is really that partitions concept. We'll get into how to actually create a partition. It's not an automatic thing from the standpoint of you just randomly throw a ton of data in there and it will be partitioned. It actually has to do with how you data model will determine your partitions. And that's why data modeling in Cassandra is such an important thing. So we'll get into that here. All right. Now, a couple key things here. Our partitions have a thing called a partition key. That partition key is what says these are all the pieces of like data that need to be stored in the same partition, so they'll all be stored in the same place within my cluster. So in this particular case, our partition key is the city column there. So Phoenix and Seattle are partition keys. Then we have these things called clustering columns. Clustering columns are how you order data within each partition. So within Phoenix, there are these three people, and they are ordered by last name and first name. Pretty simple concept, but where this comes in as kind of a critical component is a little bit down the road when we'll actually start talking about building out these data models and building out these tables to answer questions. Basically, this table is the answer to a specific question. We'll get into what that looks like in a minute here. Lastly, we got our data columns there. Data columns are simply payload. They are simply the answer to whatever your question was. So payload data, you're not going to reference them in a where clause. You're not going to really ask a question with them as part of the question itself. They are always the answer to the question, if you want to think about it that way.
Now, Eric, just before you move on here, I just want to point out that I am seeing a whole set of questions come in Slido. I'm seeing you upvote them. Thank you very much. So we are getting your questions. Awesome. We will get to those, right? So keep putting the stuff there. And I just want
anything we should address right off the bat here?
There are some questions, but not just yet, because I think you're addressing a set of them right now with this material. And I figured I'd wait until you finish up the section, and then we can go into Slido again.
Awesome. Wonderful. Yeah, we'll keep moving then. All right. So creating a table in CQL should feel really familiar to, again, anyone who's used relational database. And I know I keep jumping back to relational databases do it this way. We do it this way. The reason for that is most people in this world who are in the IT world, right, have experience with a relational database. I know from my college experience, that was pretty much all I got to use was relational databases. And I know many people are in a very similar boat. So it's a good starting point because the last 30 to 40 years have basically been dominated by the relational database as a whole. So using that as a starting point for understanding tends to be a pretty good way to kind of absorb this new information. All right, so create table, killer video dot users by city. That notation right there is how you explicitly define what table you are referencing within your key spaces. So if I had like 3 different key spaces there, I could specify a different key space dot table name and get to whatever table I was looking for. Now, you'll notice later on in the labs, we're going to use the use command, which basically sets a context for our terminal that we'll be in. So it's basically going to define killer video, that killer video key space right there, as our context. So we won't need to reference it explicitly like this. I still prefer to do the key space dot table name, even when we're using a specific context. It's just good practice. Be as explicit as possible with what you're trying to retrieve, and then you'll get it back for sure. So you got your column definitions there. We got city, type text, last name, type text. You'll notice all these types are text. That's actually not a requirement in Cassandra. That's just happens to be a coincidence here. The actual list of valid types is, I think, about a 2-page document, which, if anyone's curious, I'm sure we can get that linked. But there are a ton of different types, ints, floats, all the things you'd expect there. But it's just, there are a lot of types, and they're all used for different things. And pretty much anything you want to do, there's probably already a type for it. Then you got your primary key. Now, this is where the magic happens. So a primary key is different than a partition key. A partition key is actually a piece of a primary key. So first a little bit of terminology there that tends to trip people up. Primary key is a very specific thing. Your partition key, again, identifies the partition for that piece of data. So for that table, it's going to be divided up into things by their city name. So Phoenix is going to be in one partition, Seattle's in another, right, from our example back there. Then we have our last name and our first name, which are our clustering columns. We also have email in there. We'll jump into that in a few minutes, why we threw email in there, but there's actually a really good reason for that. So we have last name and we have first name as our clustering columns, or the way we're ordering the data in the partition itself.
Now, Eric, real quick,
yeah.
While you're talking about clustering columns, there's a question that came up over in YouTube. What's the difference between a clustering column and a normal column or a data column? Now, you were just addressing it, but since the question came up, I thought we could kind of re-clarify.
That's a good question. So a data column in and of itself has no referenceability. Like, I can't use it in a where clause to return data. The CQL console would actually scream at me and basically say, I don't know what you're talking about. I don't know where to go to retrieve you. Because if you want to think about it, let me go back to this. The primary key is kind of like an address on an envelope. Or actually, I'm going to steal something from you, David, and use your pizza analogy.
That's not mine. I stole that analogy from somewhere else. Fair enough. But it's a great analogy. I love it. Yeah.
So you got to think about it like this. If you have a food delivery service, and you call them up and you say, I want some food, and you didn't give them an address, but you gave them an order, the data columns are the order. They're whatever food you ordered. But they need to have the address. Otherwise, they're going to have to knock on every single door in the entire city trying to find, was this your order? Oh, no? Okay, I'm going to the next one. Was this your order? No, okay, I'm going to the next one. So since there's no indexing in Cassandra, like the tables aren't just default indexed or anything like that, the partition key and clustering columns are actually a direct lookup address for your data. So the partition key obviously being where in the cluster it is, and then the clustering columns themselves, and this is the part that pertains to your question, the clustering columns themselves are actually where that data is within that partition. So you can think about it like if the partition key is maybe the country and the city on your address, the address of your order, the clustering columns would be, your street name, your street number, all those things. They're the things that get you basically that last mile to your data, right? So that's how you use them. Does that answer the question there?
Yeah, let's see. For the person who asked that, I was actually looking, I want to say it was George. If you feel as though that helped answer the question you had between clustering columns and data columns, let us know. Give us a thumbs up. If not, feel free to ask a clarification question.
Yeah, absolutely. All right. So moving on. Primary keys. Oh, we have some interesting things here. So you'll notice we have good examples and bad examples there. And I'll walk through exactly why that is. Now, that first primary key we have in the good examples section is the same key we actually were using in our table, right? We have our city, we have our clustering columns of last name, first name, and email. Now, the reason that that's different from the bad example, which you'll notice is city, last name, and first name, is because we are trying to provide uniqueness to our record. Now, it sounds like city, last name, first name is probably going to provide a certain amount of uniqueness, right? Because, David, if you and I lived in the same city, your name is David Gilardi. My name is Erick ZIETLOW. There's some uniqueness there. Right. The problem is there might be another David Gilardi or another Erick ZIETLOW inside that same city. And in Cassandra, since all these things are direct lookup addresses, if two things have the same address, then they're the same thing, right? So we'll actually end up with a behavior called an upsert, where an insert could actually update and overwrite another record. So if, you know, a second person with my name comes along in that same city and gets put in this database, then we end up with an issue. So that email address being there on the end, we don't need to provide it because, you know, if we had multiple records return, obviously we could then pick the right one. But it is essentially saying that, yes, email address will always be unique to an individual. It is providing uniqueness to this row. So really, really important to understand. This is actually one of the kind of like the key concepts that once you get this, the whole world of Cassandra starts opening up to you. But understanding the way uniqueness works in your records is incredibly important. The other example I'm going to cover here just real quick, primary key user ID, you'll notice that it has a partition key, but it has no clustering columns. Now, where you'd use this is probably in some sort of a table where maybe there's a login page where you're being provided with a single direct record retrieval. So when you go to a login page and you type in, you know, your username and your password, the select statement is literally going to be based off of that username you typed. So it doesn't really matter that we're grouping like data together, because in one sense there's no like data in that table. Each record is individual. It has no relationship to any of the other data. All you care about is a single record. So in those cases, using no clustering columns is perfectly valid and is actually in many ways a good way to do things. So I'll just kind of keep moving on there. Okay. So, excuse me. So we have another kind of interesting scenario here. So two good examples. We talked about the user ID. We haven't really talked about the second one there, but I'm going to jump right down to the bad example because it at first glance, this actually looks like it might be a good table until we think about what's going on here functionally. So in our bad example there, we have a sensor ID and a logged at time. Now that's probably some sort of an IoT use case, right? Because we probably have a bunch of different sensors. We probably have they're logging every so often. That seems like it would be a good way to store data if you want to directly retrieve data from a specific sensor. Now, the problem is partitions, if you remember, are the way we distribute data around a cluster. So all of the data from whatever sensor ID you had would live in the same place, on the same node within that cluster. What that means is if you have this kind of unbounded growth, there's nothing limiting that partition from growing indefinitely, right? Every single record from that sensor is going to go into that same partition, and it's just going to keep growing and growing and growing, and that causes huge slowdowns and some really, really big issues in the long run with your tables. So what we would do is we would have some sort of bucketing situation where maybe we bucket it off day or some sort of time bucket probably would be most applicable to that particular scenario. Seeing a question here. Let's see, what is the difference between HBase or Bigtable in Cassandra? Oh goodness, where to start on that? So Cassandra handles replication very differently. David, are you familiar at all with Bigtable?
No, that's not one that's on my list.
Okay, yeah. I'm not super familiar either. I know there's some relationship from they both share some of the same roots. I don't know too much about Bigtable myself though. Let's see if one of the other team can chime in on that real quick. I'm pretty sure Cedric would be able to fill in.
Yeah. We'll try to get an answer on that. Yeah, that's
okay.
Well, one big difference obviously is Bigtable is proprietary, right? Where Cassandra itself is completely, vendor agnostic. So you're not locked into any particular vendor with Cassandra. You can deploy it anywhere. Bigtable, along with Dynamo and Cosmos, I saw some other questions come in. They're all vendor specific. You're all going to be locked into that specific vendor for those, at least in that one particular parameter.
Yeah, and there are some things around like active architecture as well that Cassandra is very unique in. There aren't really other things out there that function like Cassandra does. But we're not gonna get too deep into that today. That's a little more maybe for an operations type course. So okay, clustering columns. Uniqueness is important. I talked about this already, but just kind of showing the examples side by side. The first example there, where we didn't use the email address in our primary key, obviously that didn't provide uniqueness, because if two people with the same name lived in the same city, that would provide us with a problem. And of course, the second one there, where we have video ID and comment ID, we need some sort of time bounding on that. Otherwise, we would literally only be able to have one comment, one comment on one video. Like that comment ID would not be. Sorry, I'm getting mixed up here. We wouldn't be able to retrieve based on time, like ordering them basically, would not happen. So it would be unique, but it wouldn't be ordered.
Right.
Okay. Let's see. Rules of a good partition: avoid big partitions. This goes back to that sensor scenario I was talking about. Now, there are many other ways you can end up with a big partition, but the sensor one is one of the easier ones to understand. So sensor ID reported at, everything from that one sensor is going to get stored in a single partition. It's going to grow infinitely until we have terabytes and terabytes of data from a single sensor. Not good. One way we could actually eliminate this problem is maybe throwing some sort of a TTL, or a time to live, on that data, and expiring data on a certain time frame. So maybe we only store a month of data or something along those lines. Or another way would be to bucket it with, say, maybe we bucket it by month. So we actually have part of our primary key be the sensor ID and the month. So we retrieve data on a monthly basis versus all in one go. But there's a few different ways to combat that. Just understand that if you don't have bounding on your partition and they just grow infinitely, it'll run well for a while, and then eventually you will run into some issues. All right. Constantly growing partitions, same exact thing. Okay, so here we go. So rules for a good partition: avoid hot partitions. Now, this is one of those kind of like sneaky little gotchas with Cassandra. It's getting a little easier to avoid with some of the guardrails in Astra, but it's still something good to understand and think about. So if you have, for example, a table that is country and user ID, say that could be a fine structure, in theory, but what's actually going to happen, so picture, for example, Iceland and India. Those companies are companies, goodness,
countries or companies, whatever,
different in their size. We're talking about people in the billions with India, and we're talking about like hundreds of thousands when it comes to Iceland. So as a result of that, our partitions, if we use country as that partition key, one would have like maybe 100,000, couple 100,000 records. One would have like 1.6 billion records. So when we actually go to access that data, if we're accessing, all of the people evenly, we're going to have like 1.6 billion requests hitting one partition and like 100,000 hitting another. That creates a hot partition. That's a problem. We try to avoid that in Cassandra because we want to distribute the load to as many partitions as possible, instead of having it just hit one or two. And that, again, gets a little bit into operations. If you're curious about that, I'm sure we'll talk about that at some point here in the near future. And there's a lot of good content we've done on that. We just aren't going to have time to get into that here today. But just understand, try to avoid hot partitions, and how you would create hot partitions is generally by individual partitions that are always going to be accessed for specific data. Okay.
All right. So before we go into this exercise, I think it's a good time to start addressing some of the questions that came up with Slido.
Absolutely. Let's do it.
So let me go ahead and bring these up. And boop, there we go. All right. So, Eric, I'm not sure if you can see those, but I'm going to read them out anyway. Now, this one...
cannot. Yeah, I'll listen.
Okay, so the first one here, just curious, can I connect this database with my Python running in local to connect and play with Cassandra? Absolutely. Matter of fact, I'm going to drop a link for you right now there in the YouTube chat. Oh, you guys are seeing behind the scenes as I showed you my admin screen. And okay, so I just dropped links in both YouTube chat and in Discord. Absolutely, you can. Matter of fact, all of the major languages have support and drivers. Python, Node.js, Java, C#. There's actually all sorts of what I'll call like minor languages that I'll probably get in trouble for and such that are all supported. REST. Yeah. REST so
API, so anything you can do an API call from, you can interact with the database. Yeah, there's a million ways to do it, but yeah, Python, I do it all the time.
Yeah.
It's totally doable.
So the answer to that one is yes. I'm going to go ahead and mark that one. Now, I thought this was fun. This was getting upvoted. I saw it coming up. Can I build a mobile game using Cassandra? Now,
yeah, there is actually one that exists.
Yes, and matter of fact, Sony PlayStation is a great example. Now, that's not really, PlayStation itself isn't a mobile game, but is a game system, and Sony PlayStation actually heavily uses Cassandra in the background. Not only that, Cassandra has a really neat feature, and Eric has touched on a little bit about replication. Cassandra will allow you can have a global database that actually exists in multiple places around the world. And what's really cool about that is it means that, like, if I had some data, if I had, say, a data center that was over in the west coast of the Americas, but I had users that were over in, say, China or Australia or India or something like that, I could have data centers over in those locations as well. When I, say, change some data over in one location, it will automatically replicate out to the others, right? The point being is that you have an ability with Cassandra to be able to put your data close to where your users are. In something like a mobile game, that's actually quite important, right? Because you could have users that are all over the world. You don't want to have them incurring these huge latencies. If I had a single data center, say, in North America, but the person playing my mobile games in Australia, right? So Cassandra very naturally is built to be able to do this. It's a very natural fit for that. So I don't see any reason why you couldn't build a mobile game using Cassandra.
It's actually in use right now. I'm not sure if I can say who, but yes, it is done actively in the world these days.
Yeah. There are multiple examples of game providers that are actually using Cassandra as a backend.
Yeah. Okay, I'm seeing it on the screen. A little bit of latency here for me, but do you think that Cassandra is a substitute for our relational database? Oh, this is okay.
It depends, right? This isn't a depends question, but I think Eric, you already have something you want to say here.
Yes. So I'm gonna say I would not call it a substitute. I would call it the next iteration of what relational databases we're trying to do, by and large. It doesn't mean relational databases don't have a place, they don't have things they're good at. They definitely do. But if we're talking about scale, if we're talking about availability or any of those kinds of things, especially multiple of those kinds of things at the same time, it's an entirely different ballpark. We're the next evolution of that. That kind of data consumption. We're not a relational database. We are in many ways better, in my opinion. But that is, personal opinion. David, do you have something you want to say on that?
Yeah, and you also have to take a look at what is it that you're trying to do. If you have a table that only has 100 columns, 1,000 columns, or something like that, or rows, I'm sorry, and you want the flexibility, right, that you might get with a relational database, then there might not be much reason to go to something like Cassandra. However, if you're looking for something that can perform no matter how big your data grows, right? That's actually one of the key things that you might run into. Say, and I'm not trying to pick on one, but with any relational database, no matter how large you vertically scale them, eventually you're going to hit a performance ceiling. You're going to hit a part where you can't really get much bigger. Right. We actually had a case of someone where they were using MySQL and they had over 1 million users in this one table. The table just got too big and it started just bogging down terribly, even after adding indexes, things like that. And this is where Cassandra really shines. Cassandra was built from the ground up to be able to scale out horizontally and continue to scale up well past what you can do from a vertical standpoint. So if you have a case where you need to ensure that your scalability goes up with your application and with your data, then that's where it can be a good substitute. Also from a robustness standpoint, yes, you can have what's called high availability and such in a relational database. You can have like a master slave setup, and there are other more advanced ways that you can handle of high availability. But if you, the same. Yeah, but if you want a database, and this is why Cassandra is called the always on database, the way it's built in its peer-to-peer nature, it's leaderless. You can, in some configurations, you can lose like 2/3 of your database and still be available and still be up. It's used for lots of mission critical apps for that very reason, right? So there's another place where it comes into play. So again, you could argue, is that just a substitute? It just depends on what you're doing. So I guess to sum up, if you have a case where you have data that you need to ensure that it's going to perform at scale and is going to grow, right, and continue to grow, not just say static data of 1,000 rows or something like that. And if you have a case where you need to ensure that you have a database that is very robust and is going to stay up in all sorts of different failure scenarios, those are really good ways or really good times you might want to think about using Cassandra.
Right. Yeah, absolutely. That's a really good point. And I will point out that I think SQLite is one of the largest in-use databases right now. And it really fits into a niche that Cassandra doesn't play in, because you're not storing, millions and millions of records in SQLite. You're using it for kind of lightweight applications, and that's really not what Cassandra is for. So yeah, there are definitely relational style databases out there that do things that Cassandra just isn't meant to do. But if we're talking about apps at scale or high availability or kind of any of the fault tolerance stuff, Cassandra really is an entirely different animal. So let's see here. We maybe take one or two more, and then we should probably move on with the lab. What are clustering columns again? Yeah, clustering columns are basically how data is stored within each partition. So it's the ordering, or I should say the columns you use to order your data within a partition. Simplest explanation there.
Yeah, ordering or uniqueness, right? Ordering or uniqueness, if you need to set either one. You're actually going to go through some examples of that as we go through some of the exercises. Yes. You'll see a little bit more there. Now, this one here I saw got upvoted. Would like to see the usage of Cassandra for data extraction using Python. Now, this is something I've actually seen plenty of. Now, I've actually, in the background, I've been kind of looking for and trying to ask the team if I couldn't get somebody like a GitHub repo. There might already be an example out there for this. So give me a little time. I'm still working on this one here, so I'll just leave it for now. And then we'll just get a couple more. Peter with, so primary key contain only partition key? No, your primary key must start with your partition key. That's the only required part of your primary key is the partition key. Anything else after that will be your clustering columns, right? So your primary key can contain your partition key and or clustering columns, but it's only required to have the partition key. So primary key can contain partition key, but not only partition key. I totally over-explained that. Hopefully that was clear. If not, go ahead and follow up. And
all right.
And already loving this. Woo! Wonderful. Thank you. Appreciate that.
That's not really a question, though.
No, but that's okay. It got over. Hey, there was two upvotes. Yeah. There were two upvotes. Okay, so I think we should stop here and let me give you your screen back. There you go.
All right. So that same GitHub we were just at is the GitHub we're going to be using here. So right down at section 2, create a table. Go ahead and click in your Astra database. See the CQL console. That CQL console. I just timed out again. That's not good.
Well, I guess that makes total sense, though, if you think about it. Your session should time out eventually.
Right. All right. So in my CQL console, now the username and password we're going to use here are the same ones we used when creating the database. And you'll actually see that if you look down in the README, we actually have them there, the KV user and the KV password 1. So I'm going to go ahead and I'm going to put my user in. It's going to take it a minute, and I'm going to go grab my password. And we'll give that a moment here just to truck along. Now, this is the same thing I would use if I were connecting a driver in my driver config. I would use this username and password as well, or pretty much any other way I was accessing data from this database, I would need to provide this username and password. All right, so you'll see here I'm in a CQLSH prompt. That CQLSH prompt is going to allow me to interact directly with my database. Obviously, I could be using any number of other ways of doing this. There's even a studio thing there if you guys want to check that out. It's kind of a notebook style IDE. But it is there for you as well. All right, so the first thing we're going to do is we're going to do this describe key spaces command. Now, it does literally what you think it would do. It basically says what key spaces are on my system. I can see all these system key spaces. We're not going to worry about those right now. That's where a lot of kind of database operation stuff is stored. But we do see our killer video key space is indeed there. Is my text big enough there, David?
I would zoom in a little bit. If folks online, if you could let us know if you need that bigger, let us know, please, and we will zoom in for you.
All right, zoomed in a little bit, made it a little bit bigger. Hopefully that is easier to see for everyone there. All right, so yeah, basically it shows, you see my killer video is indeed there. All right, so next thing I'm going to do, if you remember, I brought this up earlier. If I want to kind of set my context, I can run this use killer video command, and that's literally just going to say, hey, I am using killer video, and you'll notice my prompt even pops up with the context is now killer video. So if I were to run a select from a table, I wouldn't need to provide a key space name. Pretty simple there. Okay. Now, first thing here, we're going to create a table, and this is that exact same table we've kind of been talking about this whole time, the one that has that primary key of city, last name, first name, email. Now, there's one thing I'd like to point out here that I didn't point out before, and that's the name of the table. The table is users by city. That's a Cassandra naming convention. Now, it's not enforced. It's not, something that is going to error out if you don't do it that way. But what that does is that tells me what I'm getting back. So I'm getting back user info, and what I'm providing is the city name to get that user info. So if we look at the primary key, I have to provide that. The partition key is the city. So the city name is what I'm providing to retrieve user info back. It's a good practice. It lets you look at a schema or at your full data model, and you can actually tell what each individual table is used for. So basically what it's returning and what's being provided to get that data back.
Hey, Eric, can you zoom in on your GitHub a little bit? We're getting some reports. Yes. It might be a little small. There we go. Absolutely. Let us know if that is better.
All right. Hopefully that looks better for everybody. If not, let us know. I'm going to go ahead and do that create table command, and boom. So now if I do a describe table users by city, and you'll notice I now have a table. Pretty cool. Simple, right?
Now, by the way, real quick, sorry, Eric.
Yeah.
We will give you all time to do this yourself, right?
Right. If you want to follow along, that's fine, but definitely more important that you pay attention now than keep up with me, for sure. I'll give about 5 minutes after I go through this to make sure everyone's where they need to be. Okay, real quick then, you'll notice at the end here we got all this stuff. None of this you really need to worry about right now. This is all operation stuff, and it's all table-specific operation stuff within Cassandra. Cassandra generates that automatically. You can go in if you were really into ops, and you can actually do a bunch of editing on these different values. We're not going to touch on any of that today, but just understand that's there. That's what that is. It's nothing you need to worry about, but anytime you print out your schema, that's going to show up. So just wanted to point that out real quick. Okay, so we did our describe tables command, and that's basically it for the moment. We will then do the next set of slides, and then we'll get into section 3 here, where we actually get into the CRUD operations, the good stuff. So let me go ahead. I'm going to start a 5-minute timer. I think 5 minutes might be a little bit long, but go ahead and run this example.
And I'll drop the links. Okay,
yes.
Here are, and by the way, the links I'm giving are simply, they're just in the GitHub repo. So that hasn't changed. We're going to the create a table section. That's number 2, but the links I just dropped in both YouTube and Discord have the anchors that will bring you right to that section. So that is what Eric was just going over. I did see some comments of folks saying, hey, I can't keep up. That's okay. He was just running through it, and now you get some time to do it on your own. So we'll leave you there for a moment.
Right. All right. And I think we have some music to accompany the lab.
We can do that. There you go.
Got unable to enter password. Yes, so the console does take a minute once you put in the username. It'll take a minute to pop up with the password prompt. Just give it a second, and it will show up. Password is not echoed back. That is correct. As with most Linux-style prompts, that you're just not going to see what you typed, and that's a security feature, actually. Access CQL console. If you can provide us a little more info there, that would be helpful. Let's get that resolved for sure. Just a gray screen. Okay. Looks like Bettina's grabbing that. How does Cassandra compare to ScyllaDB? I'll throw this out there. Test them side by side and tell me what you think. Scylla is an attempted rewrite of Cassandra in C++. Music brought a smile to my face. Apparently you have good taste in music there, David. Let's see. Can table columns have spaces in the case of CQL? Like in the table definition. I think is the question there. You know, that's actually interesting. I've never tried. I'm in the habit of using underscores. Bettina, do you happen to know off the top of your head on that one?
I would use snake case, right? I'm not sure. Yeah, I'll have to ask on that one.
Yeah, I know we have a couple people in the chat there who could probably provide some colored. If not, we could always just go try it ourselves, right? Let's see here. How many columns is best practice to use in a primary key? Are there limitations? That's an excellent question. So best practice, I would say it's very specific to your individual use case. Obviously, I don't want to put all of my columns in my table into my primary key generally, because I want data columns, right? Again, going back to kind of that analogy of like a food delivery service, the food that you're trying to deliver is your data columns, and you want some sort of payload there. So generally speaking, you don't really want to just throw everything in the primary key and let it go. You want to provide, the primary key should be the information you need to return whatever payload it is, not all of your data. Are there any limitations there, I guess would be the other piece of that question. Not really, not that I'm aware of. David, are you aware of any like hard set limitations? I think it's all pretty much soft limitations, isn't it?
I'm sorry, I was actually responding to something in the chat, so I wasn't listening to what you were saying.
Are there any limitations on how many columns you can have in a primary key?
I don't think technically there are, but there are practical limitations, absolutely. Because, you know, the moment, once you start going past, like, I don't know, I've actually seen cases where people have like a dozen clustering columns, but that's a lot, because remember, when you have a clustering column, when you have more than one clustering column, right, the ordering is going to be based in clustering column order. So the example that Eric gave before, where we had like, you know, last name, first name, imagine that kept going on. Well, then every single time, if I had 10 of those, every single time in my where clause, if I wanted to get to the 10th clustering column, I would have to provide them all every single time. So maybe you have a data model that fits that, and that's fine. Just keep in mind that because clustering columns are going to go in order of the, so I'm going to order, say, by last name, first name, email, whatever I had. Just keep that in mind. Practically, there's probably going to be some limitations. I don't think there is a limit, but not that I know of, but you're going to hit the practical limitation well before you ever hit the other one anyway.
Yeah. One last question here, and then we'll move on. What is the max DB size? Is there any limitation? No, you keep scaling. That's one of the beautiful things about Cassandra. It just scales and scales and scales, and the answer, simply put, is just add more nodes. Apple, Netflix, I think Instagram has done a lot with this. There are, well, and Huawei as well. There are some massive clusters out there. And you know, it is really just to solve the problem of, oh no, we're running out of space. Okay, we're gonna add some more nodes. You know, just keep scaling it out. It's linear scalability. There's no diminishing returns. So, okay,
so we're at our time, aren't we?
Yep. So I'm going to move on.
Well, and before we do that, maybe we can get some thumbs up, right? If you were able to get through that first exercise and you created the table, give us a thumbs up. Let us know that you have gotten through the exercise, please.
We have a question here. Will we delete the video after the live event? No, we're going to leave this up for a while. I think pretty much forever, right, David?
What's that?
Oh, the video we're doing here?
Oh, the video, yeah. All the videos that we do here, they persist. They will be up at the same link here on YouTube on our channel indefinitely, right? And even the materials, the GitHub repo, everything, that will exist indefinitely. We create all of our workshops, by the way, for those of you who feel like you might want to come to one of our other ones in the future or anything, we always create these with self-service in mind. So we do understand that maybe not everybody can do everything live all of the time with us. So you can do this at any time during or after the video, and yes, the videos will all persist. And I'm seeing a ton of thumbs up coming in. It looks like folks have been able to get through the exercise. Thank you for doing that, by the way. Let us know, again, if you ever have any issues or anything like that, or if you get completed with things. It's great.
I do have a couple of questions here I can take real quick.
Yeah, please.
Don't want to get too hung up on questions, but you know, I feel they're relevant here. How do you take care of data syncing between regions? Is there any lag? it's actually really, really fast. It's basically whatever your latency is, time on the wire between regions. So if you were going from like China to the US, it's I think about a half-second round trip. But the actual replication itself is handled all by Cassandra natively, and it is extremely, extremely fast. We're talking like time on the wire plus nanoseconds kind of fast here. So, you can actually sit down and do your calculation with simple kind of pinging of whatever your destinations are, and just figure out what your latency is actually going to be. Okay, I think with that, we will move on here. All right, so again, we're going to start with a relational data modeling concept, and then we're going to move into the NoSQL, the Cassandra way of doing it. So historically speaking, relational data modeling, you started with your data, and you tried to build your data in such a way that you weren't, having multiple copies of the data. You had high data integrity, and you build these models around it. And your application would then consume that data through things like joins. It would basically go and do a lot of processing on the retrieval of that data to actually get back whatever it was it needed. But on the front end, you just do inserts, right? You just insert once into, one piece of data gets inserted once and only lives in one place. So you're kind of trading operations on retrieval for limited operations on the front end. With NoSQL data modeling in Cassandra, we're actually flipping that entire thing on its head. And that's a good thing. We'll get into why that's a good thing in a moment here. But we start with our application. We ask, what is this application trying to do? What queries is it going to need to run to accomplish that? Then we build our data models around those questions. And then our data actually comes last, where we're trying to actually structure our data in a kind of logical way. Now, a lot of the people in the chat here who have worked with databases in the past probably just had a bit of a cringe moment because, oh no, we're breaking normal forms. We're not normalizing our data. You are correct. Normalization is what you would do with a relational database, right? You're trying to reduce the number of copies of your data, increase data integrity, but again, like I said, you're paying for it on data retrieval. Denormalization, which is what we're going to do here today, is actually flipping that on its head. We're taking a little bit more of a hit on the right, which actually in Cassandra, the way Cassandra actually handles some stuff, is actually not really a hit. It's kind of just, a hit from the Cassandra perspective. It's actually really, really quick. We're taking a little more of a hit to store the data in the way it's going to be retrieved, and then our retrieval of data is actually really, really fast. There's no joins in Cassandra. You'll never write a Cassandra query with a left join or a right join or an upside down join or a last Tuesday join. Like, they just don't exist. And that's a good thing. That's a really good thing, because it allows for some blindingly fast speeds that you just can't achieve with a traditional relational way of doing things. Interesting to note, too, kind of the data lake or analytics approach to storing data in a relational database is to denormalize because it is more performant. So I'll just kind of throw that out there. But again, if you went through a computer science class in university or college, chances are you probably were introduced to third normal form or something along those lines. Not really what we're doing here, and we're going to kind of flip it all on its head. So just stick with us. I promise it will be better in the long run. Okay, so we're actually sitting down and trying to build a data model in Cassandra. It's important that we think about our application and the queries associated with our application before we do anything else. So we basically have to come up with our application workflow. Now, what that means is we have to actually think about the application, say, okay, our application is going to have a login page, so it's going to need some sort of a users table. That users table needs some sort of a user ID, probably an email that they provided. We're also going to have some sort of a comments, because this is going to be maybe some sort of like YouTube-like video share application. So we're going to have comments. Those comments need timestamps associated, probably some sort of comment ID, maybe a comment payload, so the actual body of the comment itself. We're going to have videos. Those videos need something to identify them. They need titles, descriptions. And, this is just a small set of the things we would need to run this app, but this is just to show you guys an example of kind of the process we have to go through. And you can actually sit down with a whiteboard and kind of draw this out. And before you ever build anything, you can figure out have a pretty good idea of what your data model is going to look like. Okay, so then you actually have to start looking at the queries, right? So in this particular case, the particular one I'm going to look at is very, I think it explains very well what we're trying to actually accomplish here, because a lot of the data stored within the two tables we'll be building off of these two queries is going to be the same, and that's a good thing. Again, we're denormalizing our data, and that's okay. So all right, so a user opens a video page. We want them to see all of the comments associated with that video, right? A user opens their profile. We want them to see all the comments that they have put on videos. So a lot of the data is going to be the same, right? We're going to have comment payload data. So whatever that comment was, we're going to have some sort of a comment ID. We're probably going to have some sort of a timestamp in there. A lot of that data is going to be the same. It's going to overlap. But the real difference here is that we need to get one of these pieces of data by their user ID when they go to their profile, right? And the other one we need to get by a video ID because they navigated to a video. So that's going to result in two different tables, and you'll see their names here, again, using that same format that we talked about before, where we have comments by user. So that's, we're trying to get their comments back by the user ID. Then we have comments by video, so we're trying to get comments back by a video ID. These are two separate tables, and we need to construct them. Now, the select statements are going to look almost exactly the same. You'll notice the only differences are, of course, the table name, but then the value in the where clause there, one of them is going to be a user ID, one of them is going to be a video ID. Pretty simple. All right, so let's start building the table structures. What are they going to look like? Now, this way of representing a Cassandra table is actually it's kind of an industry standard. It's a I was getting his name wrong. A Chewbacca diagram.
Oh, Chewbacca. We should just start calling them Chewbacca diagrams. Yes, it's Chewbacca. Yeah, Chewbacca.
Yeah,
that's great.
Basically, it's a way to represent where your partition key is that K there. Then your clustering columns with, of course, the arrow indicating ascending and descending. Now, interesting to note that things are already by default stored in an ascending manner. If you wanted to put them in a descending manner, you could actually specify that in your create command. There's an interesting thing we can do here, though, because this primary key would have 3 parts. We can actually get by with 2 parts if we use what's called a time UUID, which is essentially a UUID with a timestamp built into it. It's a single object that kind of almost stores 2 different pieces of unique data. So it provides uniqueness but has a timestamp built in. Really cool little nifty type in Cassandra to use.
And just a point of clarification on that one. That what Eric just showed you, going from the logical data model where we had previously both a timestamp field and a UUID field, then in the physical where we essentially optimized them down into a single time UUID. That's actually really cool. But if you could go back a slide, if you implemented your table the way that Eric is showing now with both creation date and comment ID, that wouldn't be technically incorrect. It wouldn't be bad or wrong.
And it would work.
And it would work just fine, exactly. However, when this optimization step is when we're going from the logical data model, bringing it to the physical, and that's a nice optimization because then you get some really cool functionality right there in the same object. You get your timestamp and your unique ID. So,
yeah, no, that's really good to point out. Yeah, absolutely. All right, so actually creating these tables now, it should be, at this point, exactly what you'd expect. We have most of the data here being exactly the same. In fact, all of the data is exactly the same. The only difference is that primary key construction. Notice one of them is user ID, comment ID. The other one is video ID, comment ID. And of course, we have then specified that ordering by down there at the bottom and specified it as descending. So if you want to manually specify something because ascending isn't correct for your particular use case, you can do so. But these 2 tables essentially are fully denormalized. They're storing all the same data. It's duplicated data, right? I know, shock and horror. It's okay. It's okay. Storage is cheap these days. Back with relational databases, storage, when they were coming into vogue, storage was like the most expensive component of your entire system. These days, storage is super, super, super cheap. Your compute costs so much more than your storage in most cases. So we're taking advantage of that fact, and we're alleviating a lot of the load on compute at the expense of storage. All right. Exercise 3. This is going to be our last exercise today. This is where we actually get to go get some hands-on, do some CRUD operations, make some stuff happen. So
now, before we do that again, if we could go to the Slido, I think we have some questions that are coming up.
For sure.
If you don't mind, I'm going to pop over there. Boom! Look at that. That's magic. Magic, magic, magic. Okay, so I did already promise the folks who were asking about the usage of a Cassandra for data extraction using Python. The answer, by the way, is yes, you can totally do that, but you're looking for an example. I still don't have one for you, but it's on my plate. So I'm just going to move down. I'm just going to leave that there and move down. What's the difference between CQL and SQL while coding? Here's what's cool. CQL is actually a subset of SQL. If you're familiar with SQL, and you're used to doing that, CQL is going to feel very familiar to you. In code, there's very little difference, right? There are some differences in some of the commands you might have available. But if you've noticed in some of the things that Eric has already been doing, like even in the exercises that you're just about to go through, when you're, say, doing any kind of CRUD operations, any kind of DDL statements like creating a table, they're going to look virtually identical, right? They're going to be really, really close. So you should honestly feel right at home. Now, while coding, obviously, if you're literally pasting in SQL statements or SQL statements as compared to using an API, again, it's going to look very, very similar. The drivers, once you start coding a little bit and you get into what you can do with the drivers, if you're used to using, if you're a Java person, you're used to using like JDBC or something, obviously there's going to be some syntactic differences, but it's a database. It's still a database. And you use the same types of operations to insert, update, delete, read your data. It's going to feel really familiar. So that was kind of a long answer to SQL looks just like SQL.
It's a good one here. Does normalization play a role in Cassandra
tables? You were
tables?
just talking about this, yeah.
Yes, and I'll reiterate here. The answer is absolutely not. We do not normalize whatsoever. Our entire method of operation is denormalization. And again, that's a good thing because it kind of denormalization is a more performant approach, especially given modern considerations. Like normalization causes a really low usage of disk at the expense, again, of compute. So your RAM, your CPU, those things have to struggle to keep up with the reduced disk usage. That's kind of backwards for the way things work today because compute is really, really expensive. Storage is really, really cheap. So we want to reflect that with the way we're actually using our data. Yeah,
and something to keep in mind as well is, again, with denormalization, as Eric just mentioned, right, you have a lot less I/O on your read because you're only, you don't have joins and such. So you're going to literally, in your where clause, you're going to provide your partition. You're going to read where that partition is off disk and go, boom, you've got your data. Now, in the relational sense where we do normalize, how many here, raise your hand, let me see those thumbs up. How many here have had an SQL query that had, say, 10 joins or 20 joins in it, right? When I worked in relational databases, it was like a badge of honor to optimize that kind of stuff, right? And if you imagine what's going on with all those Cartesian joins under the hood at the I/O level. Imagine how many different parts from the disk you have to go and grab that data and put it together, right? That's where the optimization really comes into play. So, right, does normalization play any role? No, we denormalize, right? We totally denormalize, but hopefully you understand a little bit under the hood of why that is.
Ooh, I see a really good one here.
Is it the Docker one?
Yes. So I'm going to say something on this quick, and then I'll kind of leave it there. But do you recommend deploying Cassandra on Docker in production? What is the typical deployment model? I'm actually not going to answer this one. I'm going to tell you guys, we actually have a meetup event where Tej from Target, he is their head of their entire Cassandra infrastructure, is going to be doing a talk on exactly this. Can we get Jack, are you able to post the Eventbrite link in chat there? Highly recommend you check it out. He's basically going to walk through exactly how they're doing this, exactly why they decided to do it that way, and the advantages and disadvantages of doing so. So some really cool stuff there. The short answer is, yeah, sure, you can do it. And if you want to figure out how, come and check out our meetup. It's basically the continuation of the meetup groups that used to meet in person. Due to current events, that's a little bit hard. So we're going to try to do it in a little bit more of a remote fashion. But please come and check out his talk. He's a really good guy. I've actually met him in person a number of times. Really, really intelligent guy, and has some really good reasons for why they did what they did.
And just something to add on to the whole Docker piece, separate from the whole production discussion and such, is there is an official Docker image for Cassandra. You can also, and it's very easy to run. As a matter of fact, once we're done doing this, I will go grab those for you and I'll drop them in the chats so you can go check it out. There's also a free tool that DataStax has called DataStax Desktop. You can download that, and what's cool is you can provision whether it is open source Cassandra, whether it's DataStax Enterprise, whether if you want code examples. It's actually one of my favorite features of Desktop. If you're coding in C#, Node.js, Java, or Python, there are examples that will hook you up to open source Cassandra in a Docker image right there out of Desktop, right? You just click it, provisions, and you kind of go. I will go get those for you. I will drop them in the chats. So I find from a development perspective, Docker is wonderful with Cassandra because I can just spin the thing up and go. I'm an admin and ops person. I do like to actually run Cassandra for real. When I say for real, I just mean running it on my own as compared to an image. But from a development perspective, there's nothing beats just being able to provision it and go. So I will, like I said, I will drop some of those links. And where did my question go? It just disappeared. Oh, there it is. I see. There we go. And then this one here. Where to start from for Cassandra?
Oh yes, right here.
Yes. You're in the right place, right? And at the very end today, Eric is going to give you a set of resources. Those are the places to start when you're just starting Cassandra. We'll talk about the DataStax dev page. We have all sorts of free resources, all sorts of courses you can take in Katacoda. We have DataStax Academy. We're going to give you all those links at the end today. So I think we have a lot for you here from that standpoint. Yeah. Okay, so with that, let me give you your screen back.
Let me just do one more here real quick.
Yeah, go ahead.
What is the utility of having several key spaces in a single database? It's actually a really, really good question. There's a few reasons you'd want to do it, but from a simple usage standpoint, if I were to say be running multiple apps or maybe multiple workloads against a single cluster, granted that's not necessarily a best practice to do. Generally, I'd want multiple clusters to do that, but in the case where I was doing that, I would want to divide those up via different key spaces just to kind of keep everything separate as possible, right?
Yeah.
Also, the other big one is data replication is controlled on a key space level. So if I were, for example, using, like if I'm in Europe and I've got GDPR constraints, and so I need to keep maybe a piece of information in Germany and one in France, and I can't have those two going across, I can keep common data in a particular key space that's replicated both places, and then I can have a France key space and a Germany key space, and those would only replicate to my data centers in those particular areas. So you can actually deal with a lot of really, really hard to comply with regulations with your data and data sovereignty using key space controls. So that would be another reason to do it that way.
Yeah, one last one on the several key spaces in a single DB is if you had like a microservice application, or a set of applications, I should say.
Oh, yes.
And each one of your individual services, right, depending on what they were doing, you might want to separate them out, because part of the reason why, as Eric just mentioned, is key spaces have different replication settings, right? So depending on what you were doing with those, you get this nice kind of like clear line of demarcation where you can kind of create a key space for each of the microservices, which has other benefits, other things you can do, but it really does come down to having that control over the replication of each.
Yeah, absolutely. All right, let's move on here.
Movie magic, boom, your screen is back, Eric.
Thank you. All right. So first thing we're going to do here is we're going to actually create our two tables. That's comments by user and comments by video. So I'm going to go down here. I'm just going to copy paste again from the GitHub repo there. And boom, I have my tables. And I'm going to prove I have my tables by doing that nice little describe command right there. Describe tables. And that's going to show me my full schema here. So let's go ahead and run that. And it's going to show me my full list of tables. So if I wanted to then get, again, the table name or schema of that individual table, I could do maybe users by city, And I will go ahead and show that. So yeah, the table is created, it exists, it's there, I can interact with it now, and we'll notice that the primary key is exactly what we had discussed earlier and what we had built out earlier. Okay, moving on. So we're going to need some data if we're going to actually interact with these things. Now, one thing I want to point out about this data, this is obviously static data, this is not generated data. We've spoofed some UUIDs so that we can easily see what's going on here. For anyone not familiar with the UUID, it's basically a super, super, super long integer that is randomized and is super, super hard when you're actually just looking at raw data to just say, oh, we changed that there and that there and that changed. And so we're using kind of these pseudo UUIDs in place of actual generated UUIDs, just so that we can show you a good example of this in our lab here. So I'm going to go ahead, I'm going to copy this, and I am going to insert all of my data into my comments by user table. Now, if I do a select star from comments by user, I have data. Cool, good. Everything's working as expected. All right, so let's get some data into our comments by video table. So same exact thing, gonna copy paste that over. And let's just real quick do a select star from comments by video. And we have data. All right, awesome. Let's see, that I want to get rid of. There we go. Sorry, had that prompt kind of covering things up a little bit. Sorry if that got in anyone's way. All right, so we have all these comments. These comments now say things such a killer edit. This is such a cool video. That guy Patrick is such a geek. Yeah, totally true. Any of you who have been exposed to the Cassandra community might have recognized Patrick McFadden from a lot of the old training material and content and things that were out there online. We like to make fun of him because he used to have really funny spiky hair. So we like to make fun of that. All right. So we go ahead and do our selects. Now, interestingly enough, if I want to use a where clause, I can go ahead and copy this. I'm using the user ID. Notice it's from the comments by user table. So I'm doing this correctly. I'm getting a comment back, or all the comments from this user back, and I'm providing the user ID for that. So we can see the user ID is correct. There are 3 comments by this user, and I could actually display this on someone's profile pretty easily. This would actually work really, really well. Now, I want to show you something just so you guys will all understand, but I'm going to take the same exact query, and instead of user ID, I am actually going to use comment ID. Now, I'm going to spoil it and say this will fail, and that is okay. That is actually a good thing. You'll notice, what did I just do there? I took a statement. I did not provide a partition key. I jumped straight to comment ID and said, return some data. So essentially, I caused it to freak out, and it says use allow filtering, don't use allow filtering. Allow filtering would basically allow it to go, again, in that food delivery analogy, that says, allow me to go knock on every single person's door and ask them if they're the right person, if they have the data I need. We don't want to do that. As you might imagine, that's super not performant. I've seen people tank databases doing that. Just please don't do that. I don't even think you're allowed to do that in Astra. I think it's a protected feature. But if you're running on your own Cassandra or your own DSC, please do not do that. If you have any queries that are, please fix them. But yeah, so this would be an example of a bad query. And one of the kind of the big gotchas moving from the relational world over to the Cassandra world is, well, I could just throw an index on there or something like that. We really don't do that in Cassandra. By and large, we don't want to do things that way, and we want to get in the mindset of one query per table, one table per query. If we can absorb that, we can live with that. Cassandra will be the most powerful tool we've ever used for this. Okay, moving on. That little nugget wasn't really in the README, but I did want to demonstrate that for y'all. All right, so we're going to do our 2 select statements. Again, we kind of already did these, but just to show you what's current, We have all of our data right here. Now we're going to go ahead and we're going to do some operations. So we have this update command. Now you'll notice this update command is not an update command. We are using insert. Oh no, we have an error, David, in our README.
There are no errors in this README.
Actually, it's not an error. You can use an insert to perform an update as long as you provide the address to that exact row. Now remember, if your primary key is made up of a partition key and a clustering column, if the partition key and clustering column match a row that is already in the database, I will cause what's called an upsert, which is essentially it's an update. Even updates are inserts. Deletes are actually inserts as well. We'll get into that in just a second. But pretty much every operation you can do in Cassandra is essentially fundamentally under the hood an insert operation. So we can just kind of go all the way and just run an insert to update some data. So you remember Patrick is such a geek, and we can see that it is not in the table here. So I'm going to go ahead and I am going to do that, and then I'm going to select star from comments by video, and boom. Patrick is such a geek. Awesome. So that worked. Create table if not exists. Why do we have that one in there? I should probably have read through that again.
Because that is not one of the ones to execute. You see where that's just an example. Yeah. Just for those watching, when you go to do this yourself, it won't hurt if you execute the stuff that's in the blocks where it doesn't say commands to execute. But do notice that if there's an explicit command that per the exercise we're saying go ahead and execute, I'll have that little book there. It'll say commands to execute.
Good point.
Maybe that needs to be clearer.
I do that every time I go through this README.
I think you do actually. You almost made me spit my coffee out.
All right, so here we're going to actually do an update statement, and we're going to change Patrick. It's going to say Patrick is on fleek. I'm going to go ahead. I'm going to select, and notice that same exact record where it said geek or is a geek is now it says is on fleek. I used an update statement just like you'd expect, and essentially just to prove things. Should I do it in an editor? Should I do it, David? Is it dangerous?
That's up to you. Honestly, you're the one typing on the keyboard there.
Yeah, I'll do it. I'll do it. We'll make it work here. Where's my editor? Oh, there it is. Goodness, I am just going to make a new untitled. Okay, I am going to change this insert statement to say something completely garbledy-gook. And I'm going to go ahead and I'm going to reinsert that. So, see all the stuff if your eyes are really, really fast. Okay, so I'm going to go ahead and I'm going to perform an insert statement, and I am going to perform a select star from comments by video, and I am going to go ahead and run that command. And notice, I just used an insert statement to perform an update. Perfectly valid, perfectly doable. Cassandra allows you to do it, and that's a good thing. You can actually use it for some cool stuff down the road. So it's an upsert. All right, moving on to the last little bit here. So scrolling down, we are actually then going to delete things. In fact, we are going to delete that same exact piece of data. So I'm going to go ahead and run that. And you'll notice he's now gone. Patrick is no longer in our database. The garbledy-gook is no longer in our database. It is gone. Now, I mentioned earlier that a delete is actually an insert of types. On disk, he's actually not gone. What we did is we wrote a marker that this data is now deleted. And then there's a mechanism that will go through and make sure that marker gets replicated everywhere, kind of like double, triple checks that that piece of data, everyone has agreed to delete that data at the same exact time, and then they'll all go through at a certain time and delete that data. But from the return to user perspective, from our perspective as a user, it's not going to return that piece of data back because it says this data is marked for deletion. It no longer exists. So everything is an insert in Cassandra. All right. that is actually the end of this section. So we've performed some simple CRUD operations. We've written them in CQL. As I mentioned before, there's also some REST stuff you can play with. Same sort of CRUD operations, though. You know, your inserts, deletes, updates, all that stuff. If you're using one of the drivers, you would, again, just write simple statements like this. You can also use prepared statements. There's a ton of mechanisms and a ton of depth you can get into, but you should be armed with everything you need now to go and write, you know, a simple app and expand on these concepts. All right. Do we have any questions here before I get kind of back into the content?
Well, I feel like we should give them time to go through step 3.
Right.
Maybe.
Thank you for calling out on
yeah,
that
no
one.
worries. 10 minutes. We'll give them 10 minutes on that one.
Yeah, we'll do 5. Should be pretty quick here, but yeah.
All right, so yeah, we'll see. And if, again, as you go through step 3 and you're going through all of the materials there, just give us a thumbs up when you are good to know. If at the end of the 5 minutes you don't have enough time, that's fine. We'll give you some time.
Yeah. There's, looks like Bettina and Alex are on point there in chat.
Oh, I think some people got ahead. They already did step 3. Or you guys can really copy and paste fast.
Already thumbs up. Yes, that's wonderful. Yeah, feel free to thumbs up as soon as you got it done, because if we get, I don't know, if we get 100 thumbs ups, we're definitely just gonna move on. All right.
So, you know,
what's
by the way,
between a compound. Oh, sorry. What were you saying, David?
Yeah, I was gonna say I was going to wait a minute for this one, but Ashrith in YouTube asked how to delete a single row from table, which gets into my fun little talk about tombstones.
Yeah, go for it.
Right? Yeah, I guess we can talk about that real quick. So if you want to delete a single row from a table, you can actually delete at the cell level, you can delete the row level, you can delete a range of rows, and you can delete at the partition level. Now, the question was how to. I guess we could show the matter of fact, I guess in the...
You just use a where clause.
No,
yeah.
Right. Do we not have... I thought I had a delete in here.
We did. So this delete statement, actually, it's a little clearer to read in the read.
Yeah, I'm looking for it right now. I believe I do.
Right.
Yeah.
And we're literally using the where clause, just as we would in a select statement, to specify a specific row. So we're saying, go ahead and delete this specific thing. Now, if I wanted to delete multiple things, say I had a primary key on that particular table that had a partition key and a bunch of clustering columns, and I wanted to delete a whole partition, I'd just specify that partition key. And it would delete that partition as a single unit, and that's a really efficient way to do things. Always try to delete in the largest unit possible for your use case. So
yeah, so hopefully, Ashrith, that kind of gives you an answer. Again, it is there. I think Eric has it highlighted on the page. It is part of the exercise. When you get down to the delete step, we'll show you how to delete a row. I believe too that I usually include documentation links in there. Yes, I do see lots of thumbs up. I think folks are probably pretty good. We can let the time finish off.
Yeah. Oh, there's an interesting question here. Okay, so what is the equivalent of a like statement in CQL? Simply put, there are not like statements. There is some interesting stuff, depending on what version of Cassandra, if you're using DSE or not. There is DSE search actually allows for some of that functionality. But currently in base Cassandra, there is no like statement implemented. Let's see here. All right, we're gonna go ahead and move on.
Yeah, I love this question, by the way. Abhishek, tell me if I got that right. YouTube said there isn't a cleanup step after step 3.
Yes.
Now, if you're thinking about like a vacuum in Postgres or something like that, you're correct, right? There isn't. This is something that is automatically handled for you in Cassandra. So as you're deleting data, this still gets into the, oh yay, I got it right, woo! I'm so happy about that. So in Cassandra, when you perform a delete, you're actually performing a write. Yeah, let's just blow your mind for a moment. So what's actually happening is you're creating a delete marker. It's called a tombstone, right? And because Cassandra is a distributed database and you have the same data that can exist in multiple nodes at the same time, you need some mechanism that can protect against what happens if you have a node that's down, or you've got a network partition and two nodes can't talk or something. And Cassandra is built, again, with this robustness in mind to ensure that you have consistency of data even though it's a distributed system and stuff. It's also built to be extremely fast, and fast on writes in particular. So what happens is there's no read before write or anything like that. When you say I want to delete some data, it actually writes a delete marker is what it does. So from a cleanup perspective, what'll happen is over time, and I'm getting a little bit in the weeds here, so I'm just going to say this so you can kind of understand, but it's definitely something to follow up with in some of the materials we're going to give you later. But after something called your GC gray seconds, what'll happen is there's a process called compaction. It will automatically go through and clean that stuff out. And after your GC gray seconds, if you have some data that was deleted, Cassandra will then, it'll essentially remove that data. Right, so there's a cleanup that's happening. It's happening automatically. If that was what you were asking about, like, are we not cleaning up the data?
Yeah. Okay. One more question. I'm just gonna take this one quick and then we can move on.
Okay.
Hey, what happens inside the now part? So you remember that time UUID that we were using earlier to generate uniqueness and within a timestamp? That is simply a function in Cassandra that says generate a time UUID for this moment in time and insert it. That's all it's doing.
And by the way, Sri Chakra, in the GitHub repo, in the instruction, it may be subtle, but notice I did include links in the text to UUID in the docs, so you can take a look at it. I'm sorry, to now in the docs. That is there. So if you click on that, it will bring you to it and give you a full explanation of what it's doing. Yeah.
Awesome. All right. Well, I think we got a Menti now.
All right. Let's go over to our friends at Menti, and boom. Here we go at the Menti. So if you would all please, we'll give that a second to apparently update my, there it goes. It took forever for the to update. Yes, if you could give us a thumbs up, I'm going to go to this screen where you should get prompted in your Menti to put in a username. And if you don't, it'll pick one for you, by the way. Okay, we have a good amount of folks that are already there. That's wonderful. All right, so here's the key with this part. Speed matters, right? Speed matters in your answers. Look at your phones or wherever you're running Menti. There could be some lag in the YouTube feed. Yeah. Look at your phones for the question. Right, exactly. So look at your phones. Top 3 get swag. All right, here we go.
All right,
what is Astra? It's a gateway to the stars.
Comment,
oh, you want to read them, Eric? Go ahead. No. No, I'm not going to read them. I'm just not doing. No, I'm kidding. So it's a gateway to the stars. It is a local in-memory version of Cassandra. It's a development tool, or it is Cassandra as a service in the cloud. And let's see what happens. Boom! The vast majority, you got that right. It is Cassandra as a service in the cloud. Wonderful. All right, let's see what our leaderboard looks like. This is like one of my favorite parts of this. I see St. Elmo's already on fire. Wow, St. Elmo. Now, is that St. Elmo from the movie in the 80s? Because that was a great movie, by the way. Anyway, so the top 3 there, St. Elmo, SRG, that's, how am I going to do this? Sigurn. I'm going to go with that, and Taylor Swift. So now what'll happen is the next one.
We have 2 Taylor Swifts.
Yeah, they probably didn't put in the answer or the name, right? So they got picked. So we'll have to figure out which one that actually is. Don't try to cheat later if Taylor Swift actually wins. All right, so we'll go to the next one. Question 2 of 5. And here we go. What type is used to store both an ID and a timestamp? A timestamp ID, all the things in one ID, time UUID, or time ID?
Well, we just gave this one away by our discussion earlier.
Well, I hope so, right? That was kind of the point.
Right.
All right, let's see. Yes, it is a time UUID. That one's a little tricky. For those of you who answered timestamp ID, we kind of did that on purpose to make it so you might miss it. But yes, it's time UUID is your friend. It's a really nice object type that you can use to combine both your UUID and your timestamps. All right, so this is where the speed really comes into play. and the right answer, and you'll see this. It could be anyone's game. See, so we have Sigrun. I'm just going with Sigrun, and Kublai and Piotr in the top 3. Let's see where we go. Number 3 of 5. What is a primary key? It's the same as the partition key. Uniquely identifies a row. It's a column in the partition key, or it's the main house key. We insert dad jokes in here, by the way. Or they could just be... They don't have to be dad jokes.
That's you, David.
Yeah. They're not all my jokes. They're not all my jokes.
Oh, okay.
That's right. The primary key uniquely identifies a row. The partition key is part of the primary key. It's the only required aspect of the primary key, right? But it is not the primary key. The primary key uniquely identifies a row that could be any combination of your partition key and or clustering columns. And let's see what our leaderboard looks like. So Mike V takes the top with Taylor Swift number 1, and the second spot in Piotr and the third. Alrighty. And question 4 or 5. The song has rubber duckies in it. It makes me laugh. What is the partition key? A designated field in your table structure to partition your data. A consecutive number applied to each new record. The key to partitioning this reality from the next. An optional table field for optional partitioning. And there we go. Yes, a designated field in your table structure to partition your data. It is never optional. It's always, always required. And let's see where we ended up here in our leaderboard. This is the fun part because, like I said, it's anybody's. Yeah, look at that. Mike V is still in the top with Psy there in second place and Taylor Swift number 1 in third. And last question. Let's see what happens. This is for everything right now. Everything. All the swag. Everything. What flow is used to create data models in Cassandra? This one's very wordy. You go from data to models to application. Create data models. Models to your application, to data, or application, then models, then data. That was very wordy.
Goodness, yeah, I got confused reading that.
It is hard to look at. Yeah, you know something? I'm so sorry. I think we're going to change this one because that one is really hard. Yes, it's application. You start with your application workflows. You use that to generate your data models, and then you apply your data. Yeah, I think we're going to change that one. All right, so let's see what happened here at the end. That one's tricky. Dun, 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 dun. All righty, so it looks like Mike V took the top. Congratulations, Mike V. Awesome. And then Razvan and Dodo. Wow, it just, like I said, it's always anybody's game. Yeah, so if you're in the top 3, Jack Fryer will probably drop something here in the chats, but make sure to reach out to Jack Fryer to get your swag. And congratulations on that. And I will give it back over to Eric. There you go.
Awesome. So to directly answer one of the questions in chat earlier, what's next? Where do I get started? We are going to cover that right now. All right. So for more learning, I highly, highly recommend you guys go to datastacks.com/dev. What that is going to give you is a whole bunch of interactive training sessions. A lot of them even have basically like a terminal right there in the window where you can actually practice these individual things.
That's right.
Super, super hands-on learning scenarios. Please go and check those out. Really good resources there. They're all powered by Katacoda. We also have some stuff on Katacoda under katacoda.com/datastacks. The link is also on screen there. Please do check those out. All of our classic courses, the stuff we used to offer, the stuff that everyone basically used to learn Cassandra, is still available on DataStax Academy. That's academy.datastacks.com. Also, feel free to check that out and take advantage of that as well.
Okay. Something else I want to mention about going to datastax.com/dev with those Katacoda scenarios. So for those of you who are using, say, maybe not as powerful laptops, you have older machines or something, and you may not really have a system that's going to support a whole database or Cassandra on its own, those are wonderful because they're completely done in the cloud, right? And it's free. So what's cool is when you start the scenarios up, it'll automatically spawn a Cassandra instance for you up in the cloud for you to work with. So you don't have to worry about the resource limitations that you may or may not have on your local laptop. That's another piece about those that's actually really nice. It gives you just a really nice way you can experiment and such without having to worry about bogging down your laptop.
Yeah, absolutely. Okay, the other one, I brought this one up earlier, but I do want to reiterate because it is such a powerful tool for the community out there, and that is community.datastacks.com. Ask your questions, get a discussion going. If there's something you care about, bring it up there. Just get engaged. It is an amazing resource. There's a ton of questions already answered there. If you're running into issues or having some friction on something, definitely check it out. Please do follow us, like, comment, and subscribe, like all good YouTubers say, right? But it really does help us to get visibility and to, get our information out there on how to be successful with these technologies. All right.
And so with that, before we wrap up, I know that plenty of you are curious about how do I get my certification voucher? Ooh, we are totally getting to that. We're not, we didn't like give you like a fake thing and then pretend that we never said anything. We are
you the floor on that.
Yeah,
David.
we're going to explain all of that. Matter of fact, I might as well just go ahead and do it now. And then what we're going to do, if you'll please stay with us, is we're going to have one last piece for the survey to kind of get your thoughts and feelings and feedback, good or bad, on how you felt about today, because we do take that stuff very seriously. So in order to get your voucher, this is what you need to do. Matter of fact, Jack, do you have the links for everybody that you can drop, please? So in order to get your certification voucher for today, Jack is going to drop some links that are going to be both in the YouTube chat and Discord. There is a form that you need to fill out. You also need to do a little bit of homework, right? So what we'd like to do is create just a simple app or something like that is using Astra. Thank you, Jack, there. I saw the forms just get dropped. That uses Astra. You could even take the repository that we gave you today and literally fork it and use that if you wanted to, right? But the goal here is we want to see something from all of you. We want to see what you're out there doing. So if you would, please create a GitHub repo and just create an app. Again, you can fork our repo today and use that as a starting point and do something extremely simple using Astra. Please submit that as part of your form in order to get a voucher. The cool thing about it is that will get you a voucher, right? That is what I think about $145, and that voucher will give you a free chance at the Cassandra certification exam, right? So if you want to get Cassandra development certified or admin certified, this is the path to do it. As a matter of fact, in November, for those who might be interested, we are going to have a workshop. If you follow our Eventbrite or subscribe to our YouTube channel, we will have a workshop that actually goes through some of the very things you need to help get you that certification. So again, you'll see the information that you need in the form to get your voucher. And let's see, last thing here, let me go ahead and zoom tight. Let me go ahead and pop this up on Menti, and then we're gonna have a little bit of time to answer some of the rest of the questions.
Yes.
So if you want to stick with us, and we'll answer some of the questions and go for it. But what should we improve for future workshops? So this is in Menti. Again, be frank, right? Good or bad, whatever. We do take the things that everybody says here seriously. And let's see. Yeah, things should come through now if we see some stuff here. And this is in the Menti piece. There we go. Oh, well, I appreciate that. It was absolutely great. No changes needed. Let's see. Screen whatever you were writing a code. Oh, you mean like zooming in, making it bigger, or screenshot? Yeah, for the pre-workshop information that will allow people to get up to speed a little bit at their own pace. That's really good feedback. I appreciate that. I think that we do provide the links ahead of time, but if we don't, like to the repo, we can totally do that. Again, don't forget that all of the things that we did today will persist. The GitHub repo, you can totally do that at your own pace. Our Discord chat is there especially if you have questions afterward. I realize that once we finish today, we won't be live anymore, but you can always go to the Discord and ask us questions anytime, right? So definitely follow up. All the stuff is self-service. Provide links for the different apps used beforehand. Yeah, we could.
Interesting one.
Yeah, that's a good point. Yeah, we did add Slido today. So that was something it literally hot off the presses that we decided to experiment with. So we need to get that in there. Absolutely.
There's a lot of people asking for some more depth. I will say that while this session was specifically intended not to go very deep, it's just a very basic intro. We do offer a lot more sessions, and there are going to be a lot coming up where we get deep into the weeds on some different topics. Everything from, Cassandra and Docker. We did an 8-week session on basically full end-to-end, starting with Cassandra to having a deployed app in a cloud environment on Kubernetes. So there is definitely some deeper content out there, but that is good feedback.
Yeah. I saw another one. Oh, there we go. I almost coughed on nothing. I saw another one saying maybe we spent a little bit too much time on the questions. And I appreciate that as well. That's something that we're always kind of experimenting with. There are a lot of you here. There are a lot of questions that come up. And if you notice, we have a whole team of folks, not just myself and Eric, that are actually helping to try to answer those as fast and as fully as we can. So definitely something we're experimenting with. We try to get everyone's answers or everyone's question answered as much as possible. So thank you again for the feedback. Let's see. Yes, and by the way, for other materials, I do see a couple comments that are coming up with regard to like other materials out there. Follow our channel, take a look at the Eventbrite. We'll drop that again because we have lots of workshops that are coming up that are on varied things. We actually have Docker sessions that are going on Mondays right now. We have other workshops that are coming up, things like building apps with microservices, Java, using Spring Boot and Cassandra, all sorts of things. So if you're interested in other topics, take a look at the Eventbrite and you'll see what is coming up.
There's a really good one here. Maybe this is the last one. Okay. They want the intro song. So intros.
That song, I will get that for you in just a moment and I'll drop it for you. I love that song, actually. Yeah, that one's pretty good. Okay, and we do have about 4 more minutes here. Let's see. So I think what we could do, thank you everybody, by the way, for the feedback. And I'm not going to read them all right now. But we will
have an AMA here in the last minute or two, I bet.
Yes, so I could pop back over here to the Slido. We've got about 4 minutes left. Now, for those who were asking, I saw it got upvoted even more would like to see usage of Cassandra for data extraction using Python. I said Python friends here, right? And I dropped a link. As a matter of fact, I'll go break the fourth wall here real quick and go to the link. And I will drop it again as you see me struggle to do so. Here you go. There's that one. And I'll pop it over in Discord. There you go. So for those who were asking about the Python thing, now this is more of an ML app, to be honest. So it's not like a full-on ETL thing, but there are some examples there that may be useful for you there. And I will do that. This one, Eric, I know that you'll have something to say about this. Denorm makes it difficult to maintain consistency of the same data across multiple tables. Yeah. How do you maintain consistency?
So
go for it.
There's a statement in there called batch. Now, right off the bat, I'm going to say this is not a relational batch. It has no similarity to a relational batch. It's a completely different thing. Kind of an unfortunate naming correlation there. A batch in Cassandra is simply a statement that says these things all go together, make sure they all complete together. And it has basically a thing called a batch log that gets applied and gets rerun over and over and over until everything goes through. So there's no guarantee, like there's no, we're not talking acid here. This isn't acid, but this is providing you with essentially a really strong retry that's going to keep going until, basically we for this to fail, we'd have to have like multiple node failures. And at that point, we're talking about different issues are at play here. Like, lightning struck and things are on fire. It's not gonna fail under normal circumstances or just a small like network hiccup or something like that. So yeah, batch is the way to handle that. It takes similar data across different tables, and you run those, you say the insert statements in a batch, and it tries to make sure they all complete. So that would be the short, simple answer there.
Something that actually ties into the next question. Do you have some best practices involving bulk operations? Don't use batch. Batch in Cassandra.
Single operations.
Yeah, batch in Cassandra is not meant for bulk loading operations like you would in a relational database. They're not transactional. That's not what they're meant for. As Eric was just explaining, they are meant for those cases where you need to synchronize data across multiple denormalized tables. So I did see, do you have some best practices with bulk operations?
Yes.
Another piece there is use the bulk loader. There is a free bulk loader. That's what its purpose is in life, is to, hence the name, bulk load data into Cassandra. That is also available on DataStax Download. So if you go to DataStax Download, you'll find the bulk loader there. It is a free tool for that. If that's what you're referring to. Let's see. Can we alter the table's column data type? I think what you're asking is, can you change the data type of a column once you've created the column?
Oh, with an alter. Yeah. Okay, so alter commands are interesting because you cannot use them on anything that is in the primary key. But if you have a data column and you wanted to change a type, I do believe you can do that. At least I'm not aware of any reason you couldn't. That is not something I personally have done, a lot in the past, but I do believe that is possible.
Definitely not in your primary key though. The columns that are there.
Here's a good one.
Oh, from Turf?
Yeah. So as per CAP, CAP theorem is basically the concept. We actually have a nice diagram that I don't have on hand to pull up, unfortunately, but basically you can have consistency, availability, or partition tolerance. Choose two, and that's basically where your database is going to live. Now, is Cassandra AP or CP is the question. Cassandra is an AP system.
Defaults to AP.
So it's available and partition tolerant, but it is less consistent. Now, that's actually not a bad thing. And people almost immediately go to, well, things like healthcare and banking shouldn't use Cassandra then. That's actually false. Most banks, if you were to pull out your phone and Google like top 10 banks in the world, pretty much all Cassandra users. So banks do use it, and there's actually ways you can achieve what's called strong consistency. Again, we're getting into kind of an area we're not really going to cover, or we didn't really cover today, but there are ways to achieve strong consistency while still maintaining availability and partition tolerance. It is interesting. Every few years, there seems to be a database that comes out and says, we do all three parts of CAP. And what it all comes out down to is generally, well, no, or generally you need a massive amount of atomic clock stuff hooked up to this, and it just becomes impractical, or there is really no way to do it. Cassandra is probably the closest to functioning in a truly AP with strong consistency of any other database I've seen. It provides most of the guarantees you'd get with an actual all three system. So
okay,
really useful.
With that, that's all really the time that we have for today. We are at time. So for those of you, we try again to answer as many questions as possible. If you still have questions, you have a burning question, that is a perfect time to go over to community.datastax.com and go ask it there. Because not only are we there, but a huge community of other Cassandra committers, developers, and such, and people external to DataStax are there as well to help answer those questions. So if you really have something that's burning, feel free to ask there. Also, feel free to go to our Discord. You can ask us there as well. We are always there in the Discord. That's one way that we interact with folks after we do these workshops. So feel free to use that as well. And I think with that, I think it's time we have to end the workshop today. So thank you everybody so much for being with us today and for taking the time, a couple hours to spend with us. Thank you for the interaction and the wonderful questions. And we have a bunch of different avenues for you to learn and everything. And at any point, if you have a question and you need to follow up, just come reach out, whether it's LinkedIn, Discord, wherever. Come hit us up, and we will try to get you answers.
Awesome.
All right.
Well, yeah, just to echo what David said, thank you all for coming. We really appreciate you. You guys are the reason we get to do these sessions. So thank you from the bottom of my heart, and I'm sure David has a similar sentiment. We will see you all next time.
All right. Take care, everyone. See ya. And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.